in Qatar.
Yeah, sure. Because the neural network technology is the basis for automation. And I really believe that the next revolution will be automation. And neural networks, machine learning, data science is the basis for the next future, the next revolution in IT and ICT. So neural networks are going to stay forever.
Anything else you would like to add?
Well, I mean, every field can be automatized because nowadays we are still like in the infancy of this revolution. So think about SCADA system for oil and gas, or surveillance system, or like, you know, airport management in terms of logistics. Neural network has the flexibility to adapt to regular situation. Then the question is, what happens when there is this 0% which has not been accommodated in the neural network, how the system will respond. So in a sense, we still have to work a lot in research, because if you want solutions that can be reliable 100%, like, okay, I will put neural network in North Field for controlling the extraction of natural resources. That's okay for 99.99% of cases. But what happens if in one case out of 10,000, the neural network is presented with an input which has not been trained to respond to what we are doing? Just ignore it, provide a not adequate response. So it's really still an exciting field, I would say. If I were a student, I would do security, but I would like work on neural network and applications to security, for instance, just to have an idea. But even, I mean, things like engineers, to make things work, that's a big challenge, neural networks, sure.
Good. You, sir, work in cybersecurity, and we have a belief, as we are working on this project, we have an idea. We still don't know how to judge it, but based on what we have studied so far in our communication classes in Texas A&M, we knew that an important part or an important component of every detection system is a decoder.
Yeah.
And we might have been working on only one side. We are only doing the decoder. So there's only an encoder part. But anyway, for this project or for this idea, neural network decoder, do you think it will make detection more efficient, which will improve cybersecurity in general? Because this is what we believe, but I don't know, what's your input on this statement?
I mean, it's more general. Probably the solution we are working on is more general, because if you take any situation, any complex system, it can be seen like if you abstract it, you can write down a model for that system, okay? And in order for dealing with information that is circulating within the system, you need a coding structure. Whatever it is, it's like, you know, intrusion detection, security, it's okay. If it's billing, you have the model for billing, and information is flowing within processes. So when it comes down to the fundamentals, you have systems. Systems can be abstracted into a model. A model is based on how information is like shared within processes that constitute the model. Once you have this model, then of course it comes as a necessity the need for decoding information. So it's more general. The application can be like transversal or countless. You choose the adjective, but that's the point. Because it's the very basic structure of ICT. It requires processes that needs to communicate. So this means that you need to have classes, ontologies of information, and then you need to decode that information to an extent. How to decode information? Nowadays we use deterministic algorithms, of course, but neural network have some advantages as well as disadvantages, but they're worth investigating. For sure, they are like more efficient, for sure, so quick response. If you train correctly, you can also provide answer to some unexpected input, something that standard deterministic algorithm protocols for decoding cannot. When it comes to drawbacks, as I said before, is that probably we are like just dig the surface of the complexity of this new science, which is neural network science. Because mimicking the human brain, guys, is something should be taken with a lot of humility, because it's not an easy task. and understanding how these double networks can respond to the countless inputs is still under scrutiny. I mean, there are solutions that are in place, work very well, but as I said, I don't think I would like to have a neural network on a jet fighter, because that 1 over 1,000 or 1 over 1 million unexpected output could lead to unexpected results that I really don't want, because there are situations where you want to have 100% control. Others where you can accept 1 out of 10,000, 1 or 2 million outliers response. It's okay if one phone call out of 1,000 gets interrupted, it's sustainable from the quality of service point of view. If, as I said before, in a nuclear power plant, the process is not correct 100% of the time, probably you won't be happy with the result.
Good. Do you think we need this technology? Now, I can't just stop anyone in the street and ask them about this topic, because it is a topic for specialized people. I mean, it's not something prominent now. It's quite a trend for people working in cybersecurity and people working in engineering. But do you think we need it, especially here in Doha, especially in the region? The only thing we always think about is telecommunication. Whenever we think about neural networks or making it more flexible, making a faster data mapping, we always think of telecommunication. But do you think truly that there is a need for it, whether on the higher level from telecommunication companies or companies that manufacture mobile phones, down to regular people using their phones maybe, or using the network? Do you think that there is a need for it? There are people that are going to be affected if this thing ever come to application.
But I mean, it's already a reality in neural networks. It's not that it's not just in the lab; it's in products. Banking systems are using neural networks a lot. Financial systems are using neural networks a lot. High finance trading is using neural networks a lot. So it's already there, and people are using. And if they are using, is that because it makes profit from the retailer point of view. From the scientific point of view, as I said, there is a lot that needs to be done. So it's an exciting field. But when you ask, it's normal people affected by neural networks in the future? No, they're already affected now. They will be just more affected in the future. Nowadays, neural networks take a lot of decisions for you, for us, and we are part of an algorithm. I mean, we are affected by decisions that neural networks are taking already. So it's really something that is already there. Probably people, I mean, think about this way. Probably you have a flat TV at home, don't you? It's a plasma TV. How many people understand the concept of plasma TV, which is really sci-fi, thinking that for $1,000 you can have a 47 inches plasma screen at home, which should be a classified military technology, because it has 5,000 years of research to reach that TV. But people use it. So I'm still wondering what is the level of depth that the common layman should have with regards to technology. The more the better, but I can live with the fact that people just entrust some other entities in order of the use that the technology is employed for. Because especially in our network, they can use for classifying, screening, giving huge mass classification, which is probably not good, but can have also very good applications like healthcare, domotic, elderly assistance. So I like people to entrust someone else that makes the right decision about the usage of technology. I don't think that everyone can have the depth and the knowledge in order to express their willingness or not to continue with this technology. I'm not a physicist, I'm not a doctor, so when it comes to vaccine, I just trust people that knows much more than me, probably OMS and other entities that are full with people that have devoted their life to study, and so I trust them. The same should be for this type of neural network. People should have an idea about what they are, but then they should entrust someone else with the decision to where we deploy, to which extent we trust the neural networks, which functionalities they should be devoted to. Because as I said, even nowadays there are autonomous jet fighters actually. US is flying a few of them, which are based on like a lot of sensory stuff, plus neural networks, plus artificial intelligence, and that's okay. Do we give full control to artificial intelligence / neural network, or we retain some? So that's the big discussion that should take place, and it should take place as soon as possible, because neural networks are becoming pervasive. It's not something that is going to come, it's already there.
So, how would you advise us working on this idea, creating a decoder that uses the neural network technology? How would you advise us in terms of application? What would you recommend to us, a way of making an application of this idea, or maybe modification on this idea?
So the first thing is like, generally speaking, when you have this type of like ambitious research project, the good advice is to select an application which has a limited field, a limited scope, okay? Because you need to understand very well the data you are dealing with. And if the scope is limited, then it's good. You have sort of control of the data that can be fed into the decoder. And then, when you have done that, you need to like understand what is the need that you're trying to solve with your solution. Or some people say first start from the need. So there is a need, it can be a business need, a human-based need, a corporate need, whatever type of need. And then try to solve a need. This application can be a tool for solving a need, but then you cannot think that you can apply, especially experimental research project like this one, to general setting, because it's so complex that in order to have things work, it's a hell of a job, and usually there's a department and there are like, hundreds of people, hundreds of engineers with years of experience. In this case, the good thing is to select let's say an application where there is a need, but the scope is limited. Okay, very limited. I don't know, think about some specific application for IoT, for instance. There is a lot of sensory stuff that takes the data, and the data has to be processed. Maybe the processing which has been done